the language of the universe.
But I don't understand it.
Hello everybody, welcome back to another episode of the Math and Physics Podcast. I'm your host, Parker.
And I'm Ray, and we welcome you back to episode number 100. The 100th episode of the Math and Physics Podcast for the first time, of course, where today we are going to be talking about the notion of being alone in the universe. Just the idea. You know?
We've spoken about life in the universe before. We've spoken about alien math. That was a good episode if you want to go and watch that.
That was a fun episode.
Today we're going to talk about the implications, the philosophical aspect. We haven't done a philosophy episode in quite a while. Actually, 19 episodes ago was our last philosophy episodes, and actually one of the fan favorite episodes of all time, episode 81. So we're coming back strong. Episode 100. We're going to talk about philosophy because math and physics has a lot to do with being alive in the first place, and being alive has a lot to do with philosophy and thinking about things that we just either can't know or are very far away from knowing. Like for example, if you're imagine you're like a bug or something, you can't even start to think about quantum mechanics, right? And I feel like at any point along our journey through evolution, there will be things that are just beyond our domain of thoughts that we can have at that certain point. In 100,000 years or 1,000,000 years, if we survive, we will have a very different appearance. Our brain will be very different, and it'll be able to come up with things and reason things that we can't even think about today. We can't even begin to think about.
I think a lot of this depends on like where you draw the line of intelligence, because you were saying, a bug can't imagine quantum mechanics, but we can. So like, where is the line, right? And I think like we can also explore that today, because like in the question of are we alone, or if when we're looking for aliens, discussing aliens, we're usually talking just about general life. And I think we've mentioned this a lot of times before. Even on the previous episode with Dr. Sarah Seeger, planetary scientist, we were talking about the idea of, discovering life and how would we even have an idea if a planet would habit life. But the real question is not only if they have life, but also if they have intelligent life, which I think is super important. And we can also talk about that because I think that's truly what pushes like the concept of planetary intelligence. I was reading on that today, and I think that's a really cool idea, where the planet works as a singular society, and the intelligence is replicated through the whole system, like a virus, for example, right? Like it's how it's all interconnected, kind of like that, but obviously on a much higher scale. So intelligence is very important, and I think like that question of, hey, would a bug ask the questions of quantum mechanics? I think it's interesting to think about, because you said, hey, we maybe in 100 million years might get really advanced in our brains. What if the bug's brain also gets very advanced in 100 million years? What if the bug now starts thinking about quantum mechanics?
Well, I think you said something about the line of our intelligence, and I think that's a very artificial line. Something that it's I don't know why I thought of this, but it's like borders that you draw on maps. It's like you draw it because you want to, but it doesn't mean anything.
Yeah,
right?
You're right.
We were once a single-celled organism. When did we become intelligent? There's not one point. It just, as soon as you're alive, you're just on a spectrum, and you just kind of go up on the scale. And so, yeah, we're going to talk about that. Before we do get into the podcast, though, we do have a little bit of news. First of all, let's talk about episode 100 to celebrate this nice base 10 power of two kind of situation that's going on, you know. For
What a way to describe
to me, here's the thing: the reason I say it like that is because it makes no sense as to why it's like a big deal. It's like episode 100. It's like, okay, well, if we were in base 13, then, you know, like, it would be a different episode. Just every episode is just grand and magnificent. How about that? But what I wanted to say is that for episode 100, we're going to be doing a Q&A. We're going to be organizing a Q&A, but it's going to be off of this episode. So if you guys want to ask questions, I think we're going to wait like a week or so to gather up all the questions, and we're going to record an episode just answering your questions. The last time we did this, it was when we hit 10,000 downloads. This was a while ago. It was, I remember it was a year ago, probably exactly a year ago.
Was it
like
listener
that.
Q&A? Was that the episode that you're talking about?
It was
Listener
listener
Q&A, right? I think
it was called 10K Q&A. But yeah, if you guys want to ask questions, put them in our Instagram somewhere, put them in the comments of this video. And speaking of comments, we also have a comment of the week. Every single week, we pick a comment. If you want to be next week's comment of the week, go ahead and leave a comment under this video on YouTube. This week's comes from Dustin. He says, I'm a high school student taking AP Physics 1. Just found you guys on Spotify while jamming and found out much more interesting realities from you guys. Now I can't get enough. I listen every day on my drive to school. Thank you so much, Ray and Parker. Keep grinding.
Oh my.
So
Wow.
Thank you so much for that beautiful comment. If you want to leave a comment, then do it. And we might pick it for next week's.
Just continuing shortly on the news segment here, we have just again, usually I know we don't do this anymore, but it's episode 100, so just a little bit of update here. Our downloads are sitting at 425,000, so we're quite close to that measly 500K. So, you know, go ahead, download that episode wherever you are listening to it right now. And our YouTube is also, I think, doing okay. We're currently at 2350 subscribers, increasing as always. So thank you to everyone who continues to subscribe, continues to listen. We love you just as much as you love us. I think that's a nice way to say it.
Right.
And I think we can get into it. Can we get into it?
Last thing, we forgot to drop the NFT last week. This week we're gonna do it. So yeah, just watch out for that. I think whenever we're gonna release this episode, we'll release the NFT giveaway on Instagram. If you wanna win one out of our 10 NFTs that we made on the Cardano blockchain, we're gonna drop it on Instagram. Go on Instagram, follow the rules, you know. So yeah, let's get started on episode 100, Life in the Universe.
I think, okay, you want to go for it?
Yeah, I was just going to say, being alive is a very interesting situation, especially here on Earth. Because everything is so, so dense. There's so many forms of life that we see here on Earth. It's pretty much the perfect place to harbor life, obviously, because here we are, and here we are not alone. There are animals. There used to be other species of human, right? Which technically they're different. I think they were the Denisovans, which were in Russia, and there are also others. Do you know the name?
Well, if you're just talking about general human species, I just know about Homo erectus, like just the general, what was it called, genus, I believe, of our. I don't know too much about this. I know there were very many popular types of, different structures of human beings and whatnot. And it is actually, interestingly enough, I was reading a book, I think it was Sapiens actually, where they were posing the idea of how did, the Homo sapien single-handedly kind of take over all of the civilization, when we see like other animals like dogs and cats and whatnot having multiple different species in its own. Again, I don't think genus is the right word, but like I'm trying to talk about like the big category of genetics, And in that case, when I'm talking about like cats, for example, there are many different species of cats, subspecies of cats, right? But when you're talking about
This is why we don't talk about biology.
okay, very good point. Very good point. Again, this is very with my limited knowledge, but I still understand what's happening, just not the exact terms and whatnot. So yeah, so basically, I think it's just a little interesting. I don't know if it's I don't know if it's still not completely known, but I think there is like still a little bit of inquisitive nature into why the sapien is the last standing human. Am I right on that? Like, do you know anything about this? Like, if we know for a fact why we lasted and the others didn't?
I think it's just because we were smarter. But that's a very broad term. I'm pretty sure like the other species of humans, they were more like, I don't want to say animal like, but they were less like they were less like artistically inclined, and like like they didn't really make tools and things like that. I don't know. All I know is that humans were just, they were more like cooperative. They worked together more. They built tools. They were just better at surviving. And I'm pretty sure, like, now listen, please don't quote me on this, but I'm pretty sure like we like ran some of the species like extinct, like on purpose. Like we just like killed them because they were different. And I mean, this is still an ongoing thing, right? Like people kill each other because they're different today still. So
that's such a weird premise though. Yeah, like just killing your own species, just like it's just such a weird reason to do it as well. Like I feel like when animals do it, like sense. They have an inherent reason. I know it's just pointless really when we do it.
And this is actually very interesting because this alludes to our immaturity as a life form. And we still have, and I actually love talking about like our ancestral brains that now have like continued on through reproduction, and now we have old brains but that just recently learned new tricks. Like if you think about it, 200,000 years ago, I think that's like the rough estimate where like modern humans actually became a thing. Not much changed until like 10,000 years ago, so for a good like 190,000 years, well, okay, our brains got bigger, but I'm talking about like external things. Like we could make fire, but that's kind of like, that's how far it went in terms of like very cool stuff. And then you look at the past 100 years and you think about all of like the new things that have been implemented into our daily lives. It's ridiculous. Okay. So basically what I'm trying to say is that we have like brains that are used to doing the same thing over and over again. And just recently did we include like a whole bunch of new stuff that we just got used to very quickly, but there's still like that part of us that is not very geared towards change. For example, we use screens all the time, but screens aren't even good for you. We still use them because they're useful, right? But like our bodies aren't meant to do these things. Like our bodies aren't meant to sit in a chair all day long and just stare at a screen. But it's just this new thing that is good for our survival, quote unquote, because it makes us money. And then in our heads, we associate anything that helps us survive longer as like something that is of first priority. And so we think we need to make money so we can have shelter and food and security. How do I make money? I sit down in a chair all day and stare at a screen and do work. And so like your body and your mind are kind of up for it. And, it just does it because that's how you survive in like the modern world. Or maybe it's like the easiest way to survive.
Kind of a very interesting thing because you're kind of talking about like the whole problem with evolution kind of not catching up to where we are headed or where we want to be headed. Because We know that these screens are good. We know that flying in rockets is going to get us places, but our bodies are not accustomed to that yet. Like 0G would be much easier if our bone density was less, if this was, there are multiple factors for our human body that, that literally, first of all, you can see with humans that go to space for like a year or two. I mean, not or two. I think the longest was around a year very recently. They came back and their body literally changed, right? So a lot of it is with, okay, how are we evolving with respect to the rest of what's happening, right? And that is, I think, a super nice way to start the whole idea about talking about just, evolution, not only on Earth, but also in other places. Because in the very same logic that you used, if we look around Earth and we see hundreds of other species, can't we make the same deduction about the universe? And obviously, the unfortunate answer is no, because we need proof.
I don't know if that's unfortunate, but
okay, maybe not unfortunate, but the answer just happens to be, yeah, we would need concrete level of, we know there's life there to basically say this, right? And this whole argument of evolution being too slow is actually a very interesting topic, because that really asks yourself or tries to answer the question of whether aliens even exist. Because if evolution is in fact slow, right, and it took so long for us to get here, then the very first argument against or for basically looking for these creatures is, well, what was their rate of evolution? And when I say rate of evolution, I mean from when their planet was born in their solar system. I'm talking about an arbitrary planet here, by the way, just an arbitrary planet that happens the whole life. So when their planet was born in the solar system, how long did it take for life to, number one, evolve, and then intelligent life to then evolve? Because we know for us it took a select, as you said, took 200,000 years for Homo sapiens. 200,000 years ago, Homo sapiens were basically like the primary candidates. So I wouldn't say it took 200,000 years to develop intelligence. I don't think that's correct. But we can maybe make the argument of roughly the intelligence barrier and see how long it took us. But the real question is, two questions. Number one, can we apply the same time scale to other I don't want to say aliens, but like other civilizations, right? Like, do they work on carbon as we do? So maybe their body advances faster. I don't know, right? There's that argument. Or number two, maybe we are actually pretty old. We are actually pretty old. And maybe other planets in our galaxy are just, or not just, but like maybe a couple billion years back are just coming up. So the time difference between our existence and another civilization's existence is not that much. So maybe they are on our level of scientific knowledge. And because we haven't been able to find anything, so have they. Because if you look at our signal that we sent out, it's going on for what? Just like 70 light years, right? Or something. It's very, very, very short. It's a very short range of signal when you compare it to the galaxy, right? So even for someone to receive that signal that we sent out and send it back to us, it'll take such a large time scale that we would have actually basically evolved by then even more. So it's kind of like, I really like that evolution point you brought up, because that really asks the question of, are these time scales of evolution the same throughout the universe? And what are the implications of it?
I think that's more, I think that's less relevant, the time scale of evolution. I think like the time of like the start of the evolution is more relevant, because the time scale of evolution, how long has life been on Earth? What's the number? Is it like 3 billion? Is that the number? Like the Earth formed 4 billion years ago and life started 3 billion, or maybe not even that. Maybe it's like 400 million. I don't really remember the number. But if you think about it, like planets like Earth are like obviously peppered out through the entire universe, but stars have been forming for a lot longer than when our star formed, and which means that exoplanets have been around for a lot longer than Earth. And so what if there's a situation on another planet where there are intelligent beings there, but they started, like, they were where we are now 1,000,000 years ago, you know? Like, they were literally at our point of, like, knowledge about the universe 1,000,000 years ago. And nowadays, they could have, let's say they succeeded and they just became very, like, odds are, I have a lot of things to say. Every time I say something, I'm like, oh, I want to say this and this and this. So I was going to say, yeah, 1,000,000 years ago, they were where we are now. And they were able to become interplanetary, even maybe intergalactic, but we have yet to confirm that that is even possible. Because, okay, in theory, it's possible you could send spaceships around the galaxy with like fertilized sperm that's just frozen, and then when it gets close to the planet, it like incubates and makes a human, and then the human lands, and we can send out these spaceships everywhere in the galaxy, and then boom, we're an intergalactic species. What I'm really talking about is more like you were able to like take over your entire solar system, and then as an entire species, you were able to create this highway between stars in your galaxy where you can efficiently communicate and send things. Maybe this has to do with wormholes. There's a missing piece in like space travel that we just haven't found yet. I feel like, this is just a gut feeling. I feel like when you get to that point where you're able to do these like wild things, and we say it's wild, maybe it's not that wild, right? I guess flying a plane is pretty wild to somebody who has yet to discover fire, right? So maybe this intergalactic future is not that crazy. We just have like one thing to find, and it's like, oh, you just have to do this. But my feeling is that when you do get to that point, or even along the way, there are other things that this hidden knowledge reveals to you about possible things that we haven't been taken into consideration. For example, you realize one day, oh, this is how you can make a whole bunch of energy that is just very cheap to produce. Now you can build rockets very quickly. You can build rockets that are super efficient. It costs you hardly nothing. So now our planet Earth starts sending rocket ships everywhere. All of a sudden, because of this increased presence in our local part of the universe, we start to get noticed, right? That's just, let's say there's life on other planets, but they know some things, right? They don't want to be noticed because they know the dangers of being noticed. Remember, I was talking about our primal brains, our ancestral brains. In order to get where we are today, we had to be territorial, and we had to work as a group, right? This is my tribe. I will protect my tribe, and I will also, defend my tribe by attacking other tribes, right? I want land. I want space. I want to grow my people. That automatically means you have to be hostile to the others.
But do you believe that all other civilizations in the universe are also share these morals and share these ideas?
Okay, here's what I'm getting to, though. That's what I'm getting to. I'm saying, on Earth, it's a competition for survival. And that's just how it happens, right? It's embedded in your brain. The first thing you do when you see, let's say you're in the forest in the middle of the night, and you hear a sound that you've never heard in your life, and you see a shadow that's way bigger than you. What's the first thing you do? Do you try to shake its hand? Obviously not, right? It is embedded in your brain that it's either you kill that thing or you run away from that thing with, for your life to save your entire your being, right? And this might be a stretch, but I don't think it's that much of a stretch. I think in any context of life, anywhere in the universe, it's a competition for survival. Because if you don't survive, then, that's the whole point of being alive. The whole point of being alive is to survive and to keep your line of genes or whatever, is to keep that line alive. If you die, then it's just a dead end, right? It's the same deal with humans to bugs to viruses to anything that's alive. What does it do? It tries to multiply and it tries to survive one way or another. So I don't think it's that much of a stretch to say that like a fight for survival is a constant in the entire universe. Even when you get to the scale of an intergalactic life form, it's still a fight for territory. Because do you think it's going to stop? Right? Oh, we want to take over Mars. We want to go put people on different planets. We want to put people in different solar systems. It's all about territory. It's all about how much can you wrap your arms around and hold for yourself. And I think it's going to be the same way for, everywhere in the universe. If there are other intergalactic species out there, it's going to be, this is my territory. If you come near it, I will just destroy you. It's plain and simple. And there will be powerful species, there will be weaker species, just like there are here on Earth. And you just don't want to get in the way of the powerful ones, or the consequences will apply.
See, the thing with this is like you're also assuming that, because my understanding is if we were to discover like an alien civilization or anything really, I think curiosity would overpower maybe not overpower need for survival, but like if let's say we see an alien spaceship in our solar system, what are we just going to destroy it? Like, we're not going to just shoot a missile out of the first thing we do. I mean,
I guarantee with 100% certainty, if there's like a doomsday situation where there's a giant alien spaceship just floating above New York City,
but how do we know that's a bad thing?
I promise you, the first thing people are going to do are pull out their guns and shoot at it. I put this on my entire being. Like, think about it.
Well, you'll never really be able to test this, but
I guess unless this happens tomorrow, I don't think we'll ever be able to verify this. But I think the government is going to mobilize the army, because what else are you supposed to do? You're just supposed to put yourself at the mercy of the unknown. I don't think humans are like that.
Not necessarily mercy of the unknown, but you're trying to find out what this unknown is. Like, you don't even know that it's a threat as of now. We're just going to start killing it because you think it's going to start killing you. Like, that's not... I don't know if necessarily that's the best.
That's how it works. That's how it works, fight for survival.
But the whole purpose of, advancing as a civilization and evolution is that you have enough power to be able to take that as an option if need be. But just looking at an alien spaceship, you won't just be like, okay, let's just nuke this thing. Let's maybe find out what it is. If a bunch of people die, then we nuke this thing. Like that step is super important, because I think that itself will define. Anyways, this is a very big tangent. Because
I think there's no point in discussing this, because I don't think a situation like that will ever happen, and here's why. Yes,
of course. No, okay, sorry.
Listen, humans statistically, and because we're the only sample in the population, I don't know what the terms are, we're the only data point, okay?
Yeah.
We are probably, if we were to assume some Gaussian distribution, we are probably dead in the center of average, like, intelligence level. If we're just making the roughest estimate we've ever made, right? We are probably average in terms of intelligence.
You only have one sample. You can't make that.
I know, but if you had to make some sort of distribution, if you had to,
you can't make a population estimate based on one point, bro.
Okay, think about this. Let's say that there are there's a distribution of life forms and their intelligence levels, and there is an average, right? Most likely, we will be within 1 to 2 standard deviations, right? And if we had to
95% of the data, so yeah, probably.
Exactly. So if we had to make an estimate, we're pretty close to the middle. Let's just say we're pretty close to the middle. Now,
I mean, we don't.
here's
even,
the thing.
You can't even. Okay, sure. Let's assume this. Don't,
just let me talk.
Let's
just
say
let me
assume
talk.
this.
Okay, so that means that if we are in the middle, there are a lot of other life forms that are still single-celled or just like very simple. But there are also a lot of life forms that are like us or smarter and more capable. And wait, now I forgot because we started talking about statistics. I don't even know what I was trying to say. Oh yeah, okay. So the really, really smart life forms, like the way to get to that level automatically means that you have to at some point transcend the burdens of your past like evolutionary states. For example, we are still stuck in this tribal mindset because we have countries. Why do we need countries? Why do we need borders, right? The only reason we have this is because, oh, I was born here and I need to protect my land. It's like, protected from who? We have the internet. We all know each other. We could just agree to be one happy family, but we don't because we have these tribal instincts that we have to, protect our local area. But eventually, the more and more time goes on, we will realize that, oh yeah, this was important for survival back in the day, but now it's not important anymore. Like, it's way more important to just collaborate as a whole, and we'll actually be able to do important things. Now, the problem is that the people who are quote unquote in power don't really have like any idea of what is actually important. And that is, actually important is a word that is very debatable. But because this is a science podcast, we're going to say that anything that is science related is actually important. More specifically, just working together to grow as a species. And by growing, I mean, going to other planets, going to other stars. So if you're a very, very smart species and you are like intergalactic and all this crazy stuff, I think automatically you will have to transcend at some point these bad habits that are just stuck in your brain. And so if, let's say, we are that species and we're going around and we see a planet with monkeys on them that are exploding nuclear bombs and stuff, I really think like with our wise brains of super advanced science and all this stuff, we'll be like, oh, it's either one, they'll figure it out and they will get to our level at some point, or two, they'll just make stupid mistakes and kill themselves. But either way, it doesn't really change, what we're doing over here. Like, we have bigger plans. We're trying to harness energy from antimatter white holes and stuff in the universe. Like, whatever they do, it's like they're an ant in the crack of the sidewalk to us. It's like, why would we even waste our time going and being like, hello, okay, bye now? It's literally a waste of time. And I think by now, I guess, once again, you're not going to like this, but statistically, we would have seen a lot of these examples, right? We would have been traveling for millions of years, and it's like, oh, look, another planet with just these like average level intelligence, like life forms, and they're still like in like have you ever played Spore? No, probably not. Anyways, it's a game where like you start in the cell form and you start like you get into the tribal phase and then civilization and then space. It's just like an evolution game. And wait, where was I going with this? Oh yeah.
It's on you.
Yeah. No, I remember. So you're in space, you see, and we see just another planet with life on it, but it's like, oh, they're just in the tribe phase. It's like there's nothing that will benefit us. So to go visit them, it's like, what's the point? If anything, it's like, oh, we see like in this region of space, there's a lot of super califragilistic antimatter, so we'll go there and we'll go get it and we'll be on our way. But if there's nothing interesting about that planet, it's like, okay, well, we're just going to continue on our own, like doing our own stuff. That's my take.
Yeah, so you had a lot of interesting points on that take that I was going to answer, but I think they're very far back now. But one thing I do want to talk about that you were posing was kind of halfway through this rant. You were, and kind of the way you ended with it. What you were basically talking about is a very popular part in astronomy that you will probably see in most textbooks or really anything relating to astronomy, and it's called the Fermi Paradox. So the Fermi Paradox is basically a paradox invented by Enrico Fermi in the 1950s. And it basically is a very simple idea about, it is a paradox that basically states kind of loosely what you were stating, that if there are so many civilizations in this universe, or if it's so likely that civilization can happen and it can occur, life can occur, why haven't we seen it yet? That's basically a very loose way of putting the paradox. And because this happened in the 50s, you might know that, we didn't really know anything about really anything back then. The only thing we really knew about in terms of space was the planets in our solar system. The first exoplanet was discovered in 1990 or 1990 something, 2, 3. And it was way, way, way later than obviously Enrico Fermi. He passed away in the 50s itself. So he probably released this paradox somewhere around then. And a lot of scientists since then have been trying to, come up with ideas, come up with theories for why they probably haven't visited us. And one of the very things that you were mentioning, they're so advanced, why would they care, is a reason. But here's kind of the counter argument to that it's not necessarily, even though there is one side of it, which is they are coming to us, the other side is we can simply look for them. If they are as intelligent as you say they have most definitely discovered electromagnetic radiation. And if they have discovered this radiation, that means they're definitely sending this radiation across their planets. Like, how do they communicate? I'm assuming, like, what else? I guess there's something else probably in the universe that we haven't understood yet that could be one explanation. But as of right now, with all of our knowledge, electromagnetic radiation is the fastest and the most, I can't say secure, but is the fastest mode of communication. It's the fastest in the known universe with our laws today. So with that theory, if they are sending radio waves everywhere, why haven't we been able to see anything, right? If this has existed for so long. So this is kind of tackling your argument about, it's not about evolutionary timescale, it's about time of evolution. And that's why I brought up the whole timescale argument. Because I'm like, it could be about time of evolution for sure, but what if it's not? What if they haven't been on for that long, which is the reason why we can't see their radio waves, but just their time scale of evolution is super fast, so they're super intelligent. That could also be another reason. Right? So there are all these separate reasons, I should say, for answering this paradox that we could get into, but it's just like you can probably think of it yourself, right? It's just an idea about can or will aliens ever come to us, right? Because another theory is that they've already come, but again, we don't have any proof. We might say pyramids. We've had this discussion before, but so there's always, a counter argument to every argument for saying that this has happened. But as of right now, we have, very, very, very many planetary detection satellites for TESS, for example. It's literally called the Exoplanet Satellite System. Shoot, I forget what it stands for. But so very, very, Kepler Space Telescope, for example, literally all the Keplerian planets are all Goldilocks zone planets. So we are finding very many habitable planets in the universe, right? So Would they have it? Well, that's the whole question about the whole Fermi paradox. You know, what will happen with the fact that, hey, if we are so, if probability states that we could have, you know, been born so easily, or we could have existed so easily, why can't why can't other things in the universe as well, right?
What do you
Kind
mean
of
by
the start of
so
the power.
easily, though?
Well, life itself, maybe it took time to form, but the formation of it is very easy. In a way, let me explain that. The dawn of the dinosaurs, right, after they passed, what happened? Life was, okay, I shouldn't say over, because, like, definitely species
It was
existed.
already there,
Yeah.
though. The life was there, though.
No, but what I'm trying to say is life was basically kind of completely wiped out. Not exactly,
No,
but
it
completely
wasn't.
wiped out. I mean, most of it, again, there were animals, there were species that are living from the dinosaur age for sure, but most of it was wiped out. The point I'm trying to make
Okay.
is that
No,
life
no, no,
restarted.
no. No, it didn't. This is
What?
this is like if I told you, I want you to grow a plant with either just dirt or dirt and a seed. It's like, obviously, if you have the seed, you can grow the plant.
What's the seed? What's the seed in this case?
In this case, the seed is all of the life that wasn't extinct by the meteor.
But how did, what? Okay, no. How did the original first life, you think, form from there? Like, the point being that life itself in our formation, like, like what has happened with like single cell organisms to where we are today, like the intelligence barrier, obviously, like no one can really figure out till date. But about the simple formation of life with the elements in our planet, we kind of understand how that works. We can say that it's very replicatable given a relative composition of our environment. Remember, we were literally talking to Dr. Seeger about a similar topic, about we can't necessarily state that life will exist given the composition of a planet, but we can maybe say that it could exist. And it happened that it did on Earth because of the right conditions. But what I'm saying is those right conditions are not crazy specific, is what I'm trying to say. Those right conditions can be replicated in a lot of other places in the universe. Right. The whole query, because of all the elements that make us, are quite common.
Okay.
So
but here's the thing that I have an issue with, is that you're saying, like, just because the conditions on Earth are right, then life is easy to just like keep going, right? Is that what you're saying?
no, I'm saying life forms. Okay, the way that we know life, we understand its formation, and that formation can occur with the amount of knowledge that we have in other parts of the universe. Because there are parts of the universe that share similar compositions to what we do. And that's the point that I'm trying to make, that life can exist in other parts of the universe. The whole question is, why doesn't it?
Then, okay, but what was your entire point with the dinosaurs then?
No, my point with the dinosaurs was simply saying that life can restart. And life, if it can restart, if it can be created, well, it can restart. And if it can restart here, the point that I'm trying to make is that it can really restart anywhere. You know?
But
given again,
I really don't think restart is what you can describe that situation by. Like, life didn't restart. Life just kept going. Like, it didn't stop at all. Like, when was there ever no life on Earth? Like, in between periods, right? Like,
again,
there was life, and then there was, but listen, there was life, and then a meteor hit, and there was less life, but it was still there.
But we didn't evolve from that less life, though. We evolved from...
Then what did we evolve from?
I actually don't know the evolution.
No, that is just completely wrong.
That's not what happened, though, because I'm just thinking that because life like kind of re-evolved itself, because that's totally possible. Why is it so impossible to think that that is a possibility?
Right. Like, all of the life that has ever existed evolved from one single-celled organism. And then it branched off in a whole bunch of different directions. And then a meteor hit, and some of those branches were cut off, but then the rest of it just kept going, and humans evolved from the branches that stayed alive, right? Like life didn't begin independently a bunch of times. Like, it only happened once. It started one time, and then it evolved from there.
Yeah, I'm not actually sure about that. We can probably research it up. We can probably put some stuff in the description, or at least tell the viewers out there to look it up. Because again,
I feel like this is common.
I could be mistaken here, but I don't at least think that is the case. But anyways, that doesn't really change my argument.
I'm willing to say that you are mistaken. I highly doubt. I highly doubt that life started independently many different times. That is not the narrative.
Okay, look, I'm just like reading very short statements here, and I'm just looking again. I'm just reading like parts of arguments. So, millions of microscopic organisms were killed off. In North America, more than half of all plant species were wiped away. Recovering from the damage is a very lengthy process. Scientists working to understand how life rebounded after the extinction found that it took another 4 million years before biodiversity returned to healthy levels. So, it appears ecosystems are a lot like trust. They take a moment to break and forever to rebuild. See, they're using the word rebuild, and I use the word restart. So I don't really think that word is that incorrect. I think maybe it did not restart from single cell, but I think that's a correct word to say that's kind of what happened. You know? Again, we can definitely search this up. I would recommend you guys do too. If anybody knows about this, definitely message us, put it in the comments below. That'll be a cool thing to read up. But anyways, major point. I'm kind of forgetting my major point here now. I think my major point was just that life, because we were talking about the Fermi Paradox. So I was kind of like, if life, I was kind of just going on the point that life can exist in the universe. So if it can, well, why haven't we seen it? And I kind of was just giving like the reasons for it and like why it could possibly exist. Right? Okay. We're cool with that. I kind of want to talk about another really cool thing about if we are alone in the universe. And this is also included in every single astronomy textbook. And this is called the Drake equation. So the Drake equation was formulated by... What's his first name? There's no way. I know this. Something Drake. Damn it. I was just reading on this. So Dr. Drake formulated the Drake equation, which is basically an equation that states the number, or it equates to the number of civilizations that we can detect. Number of civilizations in the universe that we can detect. Now, it's not a statement saying that we know this number, because that's not the point of the equation. The point of the equation is simply a probabilistic identity. Basically what it does is it takes the fraction of the possibility of the number of planets or the civilization, like the possibility of a civilization to send out a signal, multiplied by the number of years that a civilization would typically take to send out the signal. So just by like simple probability, if you do probability multiplied by like the number of years, you're kind of getting like the number of possible civilizations in this case. And it basically kind of just tells you, okay, how do we estimate this quantity, right? So where am I seeing over here? I just saw, man, I thought I could find his name. I still can't find his name. Understanding the Drake equation. Never mind. Okay. Anyways, so basically, again, why it was formulated was when the first meeting of SETI was conducted, which is the search for extraterrestrial intelligence. Drake came up and he's like, hey, this is a way that we can think about how many potential planets exist, right? Now, the problem with this particular equation is that very many arguments are actually completely unknown to us. Let me give you an example. I was looking at the exact terms in the Drake equation, And here's the issue with the Drake equation. So the problem is there are three major terms that we were actually talking with Dr. Seeger about last episode that are completely unknown to us, that are simply there for estimations. And once we know, maybe 500,000 years from now or whenever we do, we will be able to plug it in and basically find a good answer. So the problem are three particular factors. So again, it's basically n equals a bunch of probabilities times the number of years. So I'm not going to go through obviously every single variable, but I'm going to go through the important ones. One of them being the fraction of suitable planets on which life actually appears. That's one variable that we don't really know how to estimate. We have a decent idea because, again, all that we're doing right now is just basically taking a cup of water, scooping a thing from the ocean and saying, yep, there's no life here, there's no life in the ocean. That's basically what we're doing right now. So this idea is get enough of these cups of water so that you can make a good estimate, at least in a range, like at least in like, let's say the galaxy, let's say just the Milky Way, we can maybe just make a crude estimate and then go from there, right? So this is all, again, local because these are just probabilities, right? You can do it locally, you can do it globally, obviously the latter being infinitely harder. The second fraction that we actually need, the fraction of life bearing intelligent life. How do we know this? Again, something that we can't really determine, but something that is there in the equation so that we can one day put it in and understand what's happening. And finally, the final fraction that's very important is the fraction of civilizations that develop a technology that would be able to send out signals such that other civilizations can detect them, right? So there are three major things. Fraction of civilizations that can live or where life can form, I should say. Second one is fraction of those life-forming civilizations that can develop intelligence. And then third one is fraction of those intelligent lives that can then relay a signal out into space that can be detected by the rest of the civilizations. So again, it's just a bunch of probabilities multiplied by then L, which is basically like the average length of these civilizations existing. Again, no way for us to know now because, interestingly enough, the estimates go all the way from n equals 1, which is only the Earth exists, to n equals 4 million. So it's like all over the place because, again, we don't really know any of these fractions. So we're just making them up and we're just estimating them in the most crude way possible. Drake, I believe, actually said that the actual answer should be somewhere around 10,000. But again, not that he actually knows, but he's estimating the answer to be that with relatively good estimates. But again, a lot of this was done in 1960. So do remember that this was actually done even before the first exoplanet was discovered. So these are just based on theoretical interpretations about our solar system, how other solar systems form and whatnot. He could kind of make this deduction. So I just wanted to bring up the Drake equation because especially when we're talking about if we are alone in the universe, I think this is a very important, equation to bring up because this is kind of tackling that exact question, right? Or at least how to mathematically determine if we are alone. Because if we are alone, I think Arthur C. Clarke, famous science fiction book writer, quoted, I'm gonna kind of paraphrase it, but he was basically like, either we are alone in the universe or we aren't. Both are infinitely terrifying, right? Because both are. Because even if we are, in fact, alone, I was just talking to Parker about this just before recording, and I think this is a super important thing. If we are, in fact, alone in the universe, remember that thing you said, Parker, where, politicians, these important people, they don't even know what's important. That will become 500 times more important. Because if we are, in fact, the only civilization in this universe, that means for some reason we've had the right conditions to be here. And with what we're doing, given this advantage or given this situation, we are ruining basically everything, right? Because what are we really doing as a human civilization?
I think if we are alone in the universe, then it kind of justifies like all of the bad decisions that we make as a human species.
It does make it a little more like, okay, at least we can say because we're the only ones.
Like we're just like we're just a science fair project that didn't work out, like whatever. But I think if we aren't alone in the universe, then it's like, okay, we have like some sort of responsibility. Like, I guess this is also arbitrary.
I think that's
But
the
it's
other way
different.
around, though. If we are alone, we have a responsibility, don't you think? Like, if we are, I mean, I guess not to
No.
anyone, but if we have the responsibility of continuing life in the universe, don't you think?
I think it's the opposite. I think if we are alone, then like theoretically, like if the Earth were to just disappear, then like nothing changes, right? But if there are other life forms out there, then it's like a community, and every part of the community, like the space community, right? It comes together, and every piece of that whole chain has its part to do. I don't know what that part is, and I don't know what the responsibility is, but it feels like it's more than just like our own playground, where like at the end of the day, like you leave the playground and then there's just sand, right? But if there's more than just sand, then it's like, it matters what you do.
By the way, I just wanted to say Frank Drake. Sorry for forgetting that. I knew it beforehand and I just forgot it in the spot. It was very embarrassing. But so yeah. Not being alone would definitely also be would also be frightening, because again, I mean, it all goes back to either the two things, right? Evolution, either time scale or just time. Like either they just had a lot more time than us. Maybe we've had a lot more time than them, or like there are so many possibilities. And obviously the biggest problem with all of this is that the universe is 13 billion years old, but 96 billion light years wide. And this is only the observable universe. So getting anywhere is a lot harder without any kind of, crazy technologies. Because the major problem is, again, whoever you can stuff in a rocket won't survive. Because, and like, yeah, I mean, that's the biggest problem with this whole endeavor, right? So figuring to be a multiplanetary species ever, we would require, man, we've had this conversation so many times on this podcast, but we would require a literal new level or a new technology, because currently the rocket engines that we're working with simply do not have enough thrust that can make us travel at relativistic speeds, which would help us with the time problem. But even traveling at relativistic speeds, we can't really travel that fast, because then there are loads of problems that then happen as well. So it's just a little nitty situation right now, where unfortunately we can't really tell much definitively, but we can make crude estimates. Crude estimates is the key right now, at least.
All right. Well,
Yeah.
if you enjoyed this episode of the podcast, which I hope you did, if you're still listening right now, make sure to follow us on Spotify, rate us 5 stars while you're at it, and also go to YouTube, hit the subscribe button, leave a comment, and all that stuff. We will see you next week for episode 101. And yeah, anything else you want to say?
Check out our IG for the NFT drop. Also, we're almost at 2,000 followers on IG, by the way. We're at like 19
that's cool.
something. So thank you to everyone who continues to follow there. Also, sorry for this week not having a post that we're going to be late, because it's always just busy. It's always just work. We always just have work, and sometimes it just slips our mind. We always have it on our mind, but not priority sometimes. It sometimes goes back in the list, and sometimes it just slips it. So just letting you guys know that, that's this current situation.
All right.
Anything else?
Well, thank you everybody for listening.
Yeah.
I am your host, Parker.
And I'm Ray. Thank you for watching, and we'll see you soon.
Bye, guys.
Peace. Oh. All right. Valid.